In the last video, we saw the classification of elements into groups on the periodic table, and we stopped with the definition for a transition metal. There are two ways to think about transition metals. So one way to think about it would be when some teachers say transition metal, they're talking about elements found from groups 3 through group 12. So all of the elements in here, some people consider these to be the transition metals. So these are the elements found in the d block, right? So we're talking about d orbitals here. So you have to understand electron configurations for this video. So that's one way to think about the transition metals, but that way is maybe a little bit too general sometimes. So there is another definition, which you'll find on the IUPAC website. IUPAC is an acronym for International Union of Pure and Applied Chemistry, and they say that a transition element refers to an element whose atom has an incomplete d subshell. So when you're talking about the d orbitals, we already know there are 5 d orbitals, and each orbital holds a maximum of 2 electrons. So 5 times 2 is 10. So 10 would be the maximum number of electrons that you could fit in your d orbitals or your d subshell. So let's count that out on our periodic table. So 10, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for our d block. So let's go ahead and write an electron configuration for a transition metal, and let's see how that applies to our definition from IUPAC. So let's write an electron configuration for iron. So here's iron right here, and if I wanted to write an electron configuration, let's say I wanted to do noble gas notation. So once again, I'm assuming that you know how to do this already, so I won't spend too much time talking about it. But if I wanted to write a noble gas configuration, I would go to argon, which is the noble gas before iron, and I would put argon in brackets like that. And that takes me to the 4th energy level, or the 4th period on the periodic table. And then just looking at the periodic table, I can say, oh, that would be 4s1, 4s2, so I can write 4s2 here. And then I'm in my d orbital. So again, just looking at the periodic table to write my electron configuration, I would say 1, 2, 3, 4, 5, 6 electrons. So that would be 3d6. And I could have written this 3d6 4s2, and right now both are considered to be correct answers. And I won't get into a discussion about the order of filling of these orbitals in this video, so I'll save that for another video. This video is only talking about definitions and identifying elements on the periodic table. And so either one of these would be a correct electron configuration. And when I look at the d orbitals, right, so when I look at the d orbitals for the electron configuration, I can see that there are 6 electrons in my d orbitals. Well, that's an incomplete d subshell, right? Because I can fit a total of 10 into my d orbitals. And so iron would be an example of an element whose atom has an incomplete d subshell. So iron is a transition metal. Let's write the electron configuration for zinc. So let's find zinc over here. So right there on our periodic table. So if I wanted to write the electron configuration for zinc, once again, I would go to the noble gas before it, which is argon. So I would put in brackets argon right here. And then once again, it takes me to the 4th energy level. So 4s1, 4s2. So 4s2. And then I count over for my d electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So it would be 3d10. And once again, I could have written that argon in brackets 3d10 4s2. So it doesn't matter. So let's think about the definition for a transition metal, an element whose atom has an incomplete d subshell. Well, if I look at the d orbitals for zinc, right, they are completely full. I have 10 electrons in my d orbitals, and so this is a complete d subshell, so this does not meet the definition for a transition element. Now, also in the definition, it talks about cations, right? So let's think about the cation that zinc would form. Zinc would go to zinc 2+. So if I wanted to write the electron configuration for zinc 2+, I need to think about where does zinc lose 2 electrons? So if you're going from a neutral atom of zinc, right? To zinc 2 plus, you would have to lose 2 electrons. Well, I already know that those 2 electrons are going to be lost from the 4s orbital. So you're going to lose these 2 electrons right here on your electron configuration. And so you'd be left with 3d10. And once again, you have a cation that has a complete d subshell. You've completely filled your d orbitals. And so the cation does not have an incomplete d subshell, which means that it doesn't fit our technical definition for a transition element from IUPACs. And so once again, there are 2 ways of thinking about it. One's a very general way. So you might hear someone talk about an element from groups 3 to 12 as being a transition metal, or you might find people who are a little bit more particular about the definition who go along with IUPAC. So it's good to be aware of both ways of thinking about it.